Hi everybody. This is a video on resonating structures, and I will be making some effort in explaining what is a resonance is all about in chemistry. Resonance means a molecule which can exist in more than one Lewis dot structure. So there are many molecules that we are going to talk about today. The first molecule what I'm going to explain today will be the molecule called ozone. We know ozone is a molecule which has a structure of this sort. When you talk about ozone, how to go about with the structure? Ozone molecule has oxygen, which is the electronic configuration 1s2, 2s2 and 2p4. So there are totally 6 electrons on a whole. So a single oxygen molecule can have 6 electrons with it. You can see these 2 electrons are common for these 2 oxygens, and these 2 electrons are common for these 2 oxygens. So I'll be putting 1, 2, 3, 4, 5 and 6 here. And since there are already 2 electrons given, 1, 2, 3 and 4, I'll put the third electron over here. Followed by that I'll put another 4 electrons of this over here. The remaining 2 electron I'll put it over here. That is nothing but the pi electron. So if you look into the Lewis dot structure, you can find in ozone one oxygen molecule has a formal charge 0. This oxygen has a formal charge +1. This oxygen has a formal charge -1. Simply speaking, there are totally 6 electrons of the oxygen are in contact with the oxygen. The 6 electrons of this oxygen are in contact with this oxygen. While if you look at this oxygen, you have 1, 2, 3, 4 and 5. We can take that this is also the 6th carbon, the electron, but it is not with it. So the 2 electrons of this oxygen has got to be donated by this oxygen to this oxygen. In other words, the electrons of this oxygen have transferred to this oxygen. And if you look into the Lewis dot structure, this is what the structure is. And if you look your NCERT text, the structure would have been given like this: O, double bonded O, and the 2 electrons of this oxygen will be here. The another 2 electrons will be here, while the 6 electrons will be here. Now you can see that one of the lone pair over here will become a pi cloud, and this pi cloud can become a lone pair of electron. So the above structure can also be written in this form, that is O double bond O, O single bond O. So now you can see that these oxygen's electron is retained, while there is a new electron that have come into picture, while this electron has formed the pi bond over here. So the remaining 2 electrons will be here. So this is how you have to write the resonance structure for ozone molecule. Okay, fine. What is the next molecule that we have in our NCERT? The next molecule what we have in our NCERT is carbonate molecule. There is a question, sir, can I call that as carbonate molecule? No, it is a carbonate molecular ion. It is an ion. So carbonate as C double bond O, 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 and I will put it like this. Sir, why you're putting in a dot structure? The same way I can write for ozone also, where in ozone molecule, the same ozone molecule altogether can be depicted in a single form, which can be written as O single bond O, while the 2 electron is popping, or I can say that 2 electron is just moving between this oxygen and this oxygen. So I can show that using a simple canonical form like this. And this is a simple canonical form what you normally talk about. Can you see? Yes. So here I will not talk about whether the electrons are with this oxygen or with this oxygen. So the electron is moving between these two oxygens. So this is the basic idea that you need to have with respect to ozone. Very similarly, carbonate do have this kind of structure. Let me explain how the carbonate molecule is going to have a resonating structure. So we know carbon atom has how many electrons? 1s2, 2s2, 2p, 2. Totally 4 electrons in its valence shell. As you know, oxygen will have 6 electrons in its valence orbit. So I can say carbon is having 6 electrons, 4 electrons with it, I'm sorry, 4 electrons. So I'm depicting it with the green colored dot. Now the oxygen, which has the 6 electron, is going to get bonded with the carbon. Am I right? So these starred electrons, red colored, belongs to oxygen, while the dotted one belongs to our normal carbon. While the other oxygen will give 1 electron to this, and the remaining 2 electrons will be here. Again, the another oxygen will give 1 more electron to this dot, and the remaining oxygen electron will be here. Now if you look into the structure, 6 electrons of oxygen is here, 6 electrons of oxygen is here, here also 6 electron is balanced. I can write this in the bond line form as C double bonded O, single bond O, single bond O. Since I have 1 minus left over, I will put that minus over here, and the 2 lone pairs here. No, I just want to put it as an electron put. It's your call. You can do it in the way however you want it to be. But remember, whenever you put a bond like this, make sure you can show the canonical forms for this. Let me repeat, canonical forms are nothing but the forms, or resonance forms are also called as the canonical forms. Now what I'm going to do, this electron shifts over here and this electron occupies its position over there. So my next structure will be like this. C in the center, where the topmost oxygen will have the minus now. This oxygen will have a double bond, while this oxygen will have a minus. Again, now you found there is a double bond with this oxygen and this carbon, between this oxygen and this. So this oxygen has no double bond. So next time, this is going to give its electron, while this will move over here. So immediately my next canonical form will be of this sort, where the O minus will be here, this will become a double bond, and this becomes a O minus again. So in general, I can write all together in a single form like C double bond O, 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 and the electrons are moving here and there in the carbonate molecule. So this is how a carbonate molecular ion resonance structure is being explained. Hope it is clear, right? So next, let's go for many other ions similar to this. This is called as the nitrate ion, which has the formula NO2 minus. So N double bond O, O minus, another oxygen is coordinated. So this electron goes over here, then the electron upon the oxygen moves. So this coordinated oxygen has nothing to do, so it becomes O minus and double bonded O. So you can see the electron is moving between the two oxygens. So I'll just put a different color so that you'll be able to differentiate the oxygen and nitrogen. So is that clear? Again, it moves over here and this comes over here, so you'll get the same. So you can write the same equation in this form. Even in a molecule like benzene, you have the same. This is a benzene ring. where the electrons moves like this. Hope the video was helpful. Thanks for your time and patience. Bye. JSP.